Hey guys, how's everything going? This is Jaser. So yeah, Rec 19 is finally coming, and I think it's good for us to get prepared for the new APIs, right? One of them is this useOptimistic hook. I spent last 4 days diving into its internals, and I must say it is not as easy as it seems. To understand this hook better, or if you want to read the post on my blog, Jason.dev, I'd suggest these three blog posts to be read as a prerequisite. In this video, I'm going to briefly touch these topics as well, so you don't need to worry. Cool, let's begin. The first one is what is optimistic UI? I put two demos on these like button we see everywhere on websites. The first one is implemented in a non-optimistic way. It's the naive approach, which is update the UI state after the API response arrives. Yeah, if I click this button, you'll see that it will toggle the state nicely after some delay. That is the mock of the API round trip. And this one is always fail, so you can see that after a certain period of time, error message pop up and the state is not changed. Also, I've grayed out the button during the API fetching. This is to avoid duplicate API call and avoid the race condition. So it works perfectly, but it's laggy. We don't want this because like button is the most lightweight interactions on the website. Why should we make it so laggy, right? Okay, so the improvement is optimistic UI. The idea is simple because we'd expect the API calls to succeed most of the time, like, I don't know, 90%. Then why don't we just update the UI ahead of the API call and only revert it after the failure? It makes sense, right? So this is a result. When we click it, it will be reflected right away. And then if it is error, it will revert. So this is the trade-off we will choose, and it looks perfect. I think suit the mentality, right? When I click it, I want some instant feedback. So here's how I implement it. Because we need to handle the revert and also the race condition. If there are multiple API calls ongoing, and also they have different payload, I don't actually know how I should revert, right? Maybe we could pass a another another parameter about how to revert, but that actually depends on the optimistic state. Anyway, I store them into two states. One is true state. Another one is optimistic. The optimistic state is used to render the UI, and I'll update both of them on success. And if there's error, I only update the optimistic one. Also, I use the ref, call ID ref, to discard the API request except the last one. So the result is, no matter how quick I click them, it'll always reflect nicely. You can see there's no flickering. And also for fail, it will never show a success state because it's false all the time, the true like state. So yeah, this works perfectly, but it's not bug free. So you don't use this code in your production. This is only for demo purpose. But from this case, you can see that it's actually not that easy to get it right. There's some API design, how we can make it easy to use and bug free. And because it's all about API requests, data fetching libraries already supports this actually. Relay has this optimistic updater. Works like a set state in React. It will update the local store, according to the response from the remote store. As far as I know, that relay actually heavily relies on the ID to sync the state, sync the store. So if you return a piece of code which has the ID, it will automatically update the local store. So we don't need to manually update the store. So this is the power of relay. And it has this optimistic updater in this commit mutation. Yeah. I also have a video explaining it, but it's not in its internals, but just how to use it. If you're interested, take a look. SWR, one of my favorite data fetching libraries, I use it all the time, also has this optimistic data in this mutate API. It is not a function, but just to pass in the data. Also, together with this rollback on error, set to true, we are able to implement something similar. Here's the official demo on SWR website. Let's add one message. You can see the toasts pops up after, I don't know, 2 seconds. Or 1 second maybe. And for 2, you can see the fails, and the UI, it first is, the 2 is rendered optimistically, and then it is reverted on error. 3 failed. So yeah, it works pretty nice. We can try something similar by wrapping this optimistic state into a reusable hook called useAPI. Here's what I did. Again, this is for demo purpose. It's not for production usage. It's full of bugs. Yeah. Okay. So here's a 2-state, same as before, and we will. This fetcher is for the initial get API, and it will expose this mutate method. In it, it'll handle the optimistic data option. See, we will use the optimistic state to render the UI, and this updater, we call this remote API, and then when it succeeds, we will update both the optimistic state and the true state. And when it's error, we will sync this true state to the optimistic state as a rollback. Yeah, this is it. It's actually pretty straightforward. Again, do not use it. It's full of bugs. And this is a rewrite with our demo using this new use API we created. And you can see that it works perfectly no matter how many clicks we click. It always ends up in the right state. For this is a succeed case, and this one is failure case. You can see that it will fall back to this, roll back to this non-selected state. Yeah, works good. Cool. Yeah, the most exciting part is the application logic, because we've already put the optimistic updater into use API for the app.js. It looks very clean now. For the toggle option, it doesn't have any clues on the optimistic state. It's only use this mutate, and then we will pass in the optimistic data, and that's it. This data will give us the optimistic state, and it's synced with the true state. Cool. And yeah, that's enough for the background. Now let's take a look at the actual useOptimistic. This is an official demo. I just borrowed it from the official homepage for React. Here's the demo of it. Is when we send a message 1, it will show sending, and once the API is done, it will be replaced with a true data. 2, 3, yeah, looks pretty nice. And here is the syntax for the useOptimistic. Here is the useOptimistic. It will accept the messages. This message is actually from another state. We can think of it as the true state. And here is this reducer. This is basically an easy way to, if you want to handle just an event and create a state based on the event. Yeah, this is very handy. And this is a set state for the optimistic state. Here is a bit tricky. We don't have this thing yet. This form actually is no longer a normal HTML tag in React 19 anymore. It actually accepts, well, it's more than that. It's not. It works the same, but it's more than that. If we pass in an async action to this action attribute, this form will now have its internal state in React realm. So here's an async function. You can see that it actually updates the optimistic state right away, same as what we did, and then it will call the API. The thing is that it doesn't handle the error or rollback explicitly. This is the most interesting part. Okay, Yeah, here we added, and this will be reduced. So you can see that when we type 1, this reducer will be called, and this sending true, this one message of 1 and sending true will be set into the optimistic state. Yeah, and then it will show sending. And once it's done, these messages will be the true state, right? Yeah, await send message. The send messages. Where send the message? And yeah, here, once message is sent, it will put this message into the true state. And once the true state is updated, this optimist state will be synced to that as well. So here is something different. For the normal use state, we cannot actually update the state without doing it through the dispatcher, right? But use optimistic actually listen to these changes without the set state. So this is something different comparing it to the use state or use reducer. Cool. The syntax looks a bit similar, but it's actually pretty mysterious to me because there's no explicit error handling. Cool. Let's see how it works. Okay, before we dive in, we can actually try to implement something by ourselves. Here's my try. Of course, don't use it. It's just a demo purpose. So, yeah. So here's what I did. I created an optimistic state, and I'll sync the state to this optimistic state by this use layout effect because React doesn't expose any API for us to directly modify the state, except through the set state. So I have to set state here. And then I'll expose this dispatch. So it's actually pretty simple, right? And actually it works. Let's give it a try. 1. It doesn't work. You can see that when I type, there's no like a optimistic state. Sorry, my tongue is just twisted. There's no optimistic state being rendered. So what's the problem? The problem is actually the form. The form, this async form. You see that optimistic state in useOptimistic is is tied with these async functions. One of them is form action. So it doesn't work that way nicely with other things like useOptimistic created by us. We cannot use this hook with this form async action. So here, we just switch it to unsubmit, which is the like a old school, right, approach. Inside of it, we just approve the default, and then we get the form data. Other than that, the code will be the same. Let's give it a try again. 1, yeah. 2, yeah. 1, 2, 3. Okay, so here is something very interesting. You see, if we type it in one another, it works pretty much the same, but internally it doesn't. Okay, if we quickly type into multiple messages, you can see the 1, 2, 3. The pending state will be dismissed, and the actual state will pop up one by one. While in the official demo, it's a bit different. Like 1, 2, 3. You can see that the pending state will be dismissed at last, and there are some overlapping. It's actually the caveat. We will talk about it soon. But just to let you know, it doesn't work exactly the same, so it's not a full replacement. It's just a demo purpose. So I said it's kind of works. Okay, cool. So how does useOptimistic work internally? Here is the description from the official website. It says it accepts some state as an argument and returns a copy of that. That can be different during the duration of an async action, such as network request. Yep, this is important. So it's supposed to be used together with async actions. You provide a function that takes the current state and input to the action and returns an optimist state to be used. Yeah, otherwise it looks pretty straightforward. So this about let's just jump straight to the first variation of the useOptimistic. As we know that for each hook, basically there's mount phase and update Mount is the initial mount. It's works slightly different than the update. Okay, so for mount optimistic, what does it do? It actually creates a hook, a state hook, basically the same as useState. You can refer to my blog post here. It's basically the same. We create a hook, create an update queue. There's empty queue though, and then we'll create a dispatch function. Yeah, and for this dispatch, we create an update. This one is a bit different. For the update, we have the lane forcefully set to sync lane. For the normal state, the lane is dynamically decided based on a lot of factors. If we are under transition, then this will be low priority transition lane. But here, for optimistic, we don't want it to be up like a transition because it's important, right? We actually want this optimistic stuff to be rendered as soon as possible. So it's set to sync lane. The other one is revert lane. This is new for optimistic state, only for it. This revert lane is a flag actually used to say, okay, we will revert the change on this lane. So you see that request transition lane. So if there's a transition now, then this will be the same as the transition lane. This means in a low priority, when this transition is worked on, these updates will be reverted. How it is reverted, we'll see soon. Okay, so the other stuff is pretty the same as useState. It will enqueue the updates, and the next render, before the render happens, this state will be organized and just attached to the fiber so it can be processed. So schedule update, yeah, let React knows that it should re-render everything at appropriate time. Cool. Well, now let's take a look at the update optimistic to see how the optimistic update is handled and reverted. Okay, so internally it used this update optimistic implementation. The first mystery is solved. As I mentioned, we actually don't know how we can update the state without the dispatcher, right? So here it is. This hook will treat the data as a pass-through and always sync to the base state of the hook, a state hook. So you see that it just updates the state directly without triggering anything. Here's the thing. So by this, we know that actually for the update optimistic state hook, the base state is always the true state, and it just the optimistic updates like it varies. Yeah, let's go to the update reducer here. Okay, before we begin, I suggest you read this post, but there are 3 things I'd like to point it out. The first one is base queue. This is for all the updates for state hook. Remember that in React concurrent mode, there might be multiple state, right? Ongoing, but with different priorities. So the queue holds all the updates. And the base state, we need like if you think of the updates as a middleware, we need the initial value. So these updates will be applied to this base state in order one by one and derive the final state. The memoir state is the actual state that is being rendered. It's different from the base state because, as I said, on each render, not all of the updates are processed. So the memoir state is actually not the final state for the actual final state. There are still pending updates. They need to be applied on a base state and to derive the actual the new state. So it's are not always the same. Cool. So this explains why we need updates the base state in the optimistic hook, right? Yeah, because all the optimistic updates are intermediate ones. They are transition. They will be discarded in the end. So we need the base state to be always up to date. Cool. Let's take a look at the actual update reducer. This is the same function used in useState. Well, which is actually used the same use reducer. So it's the same. This is while loop to handle all the updates here. here's is the same for all the state hooked. If it is the lane of the updates, the current working lane, then we will process it. If it's not, we will skip it. So by skip, you see that by skip, we're still copying the updates and put it in the next render queue. Because we skip it, it doesn't necessarily mean we'll discard it. We will keep it and process it later. So we clone the hook or clone the update and set it to the update queue. Yeah. And if it is not, we should not skip it, then we should commit it. By commit, I mean it will be applied on top of the base state or previous state and create the new state. And eventually this new state will be used as the memoir state. Yeah, memoir state and being rendered. Cool. So here we check if this update is optimistic update by checking, by looking at its revert lane. If it is empty, then it means it's normal update. Here as it says, if there were early updates that were skipped, we need to leave this update in the queue for next render. That's true because say there are 3 updates. The first 2 is low priority. We process the third one as high priority. After committing, actually the state rendered is not accurate, right? Eventually. So we need to keep it in the queue and render it for the future. Cool. And here's a very important flag. We'll come back to it soon. But just remember that if the update lane, the lane current being rendered is the same as current action lane, then we will keep this flag as true. This means that any update that is committed during the transition, most of the time, we should treat it as the update is depending on the transition. Transition is async, so if the transition is not done, we should not commit. That's the idea. We'll talk about it soon. Cool. So otherwise, it is optimistic update. As we said before, if current rendering lane is the revert lane, we need to revert the optimistic update. By revert, I mean it's not skipping anymore. Skip meaning the update is still kept in the update queue for next render, but ignore here is just you can see that it's just ignored and continue. There's no commit of this update. This will be removed from the update queue. Yeah, this is by design. It's a revert. It means that it's done. We should revert it. But actually, it's more than that. How should we know it should revert or not? The assumption is that when we render this revert lane, if this revert cause some state change, we will check that the state change is result from the transition or not. And if the transition is still ongoing, and we will just stop this revert from happening. So it tries to revert, but actually it will fail if the transition, the async action is still ongoing. Okay, we'll come back to this soon. Okay, cool. So we should revert it. Otherwise, we will commit it. Commit it, and then we will update the lane to no name. No name means 0. 0 means it will be tried on every render. So if we still keep it as sync lane, then we will re-render the transition lane with the low priority. It will not be processed. We don't want that. It's optimistic. Yeah. You see that even if we commit it, we still keep the updates in a queue, because it's still not the time to do the revert. The revert actually depends on the revert lane here. Yeah. Cool. And here update is committed here. The reducer will call the action, create a new state, and this is what we said. Every time if the states, the eventual memoir state is changed, and the current rendering lane is the same as the current transition lane, then it means that it should suspend. It means that the state update is depending on some async option. We need to wait that. So yeah, it is throw. The promise is throw, and it will find the closest suspense boundary. And for more of that, yeah, please refer to my post about suspense. And but simply put, then there will be a callback attached to this promise. Basically, when the promise is resolved or fulfilled, React will try to render everything again. At that time, this transition is already done, so this will be null. There will be no throw, so the promise will be, the optimistic state will be reverted successfully. Yeah, that's all for this update. It's quite a lot. Let's summarize a little bit to, summarize it. An optimist update has revert lane, and the lane is set to sync lane to make it high priority to render the optimistic one. And if the rendering lane is revert lane, we will revert it by not adding it to the next queue. But if the async action on the transition lane is not yet complete, it does suspend. So the revert will not actually be committed in the end. The revert will be tried again after the sync action is done. Great. So our last piece of puzzle is, what is this async action? This one is, I'll put in a different post called "How does use transition work internally?" Simply put, there's actually a global transition object to indicate, like a global flag, to indicate we should treat the state update, the action, to lower priority or not. That's transition. And the start transition is actually to set this global transition object and revert it back after it's done. So under the scope of this call, all the set state will actually be attached with a low priority, which is transition lanes. This is a little background on transition. And for the form, it actually now accepts this as an async action. We won't touch every aspect of the form here. It will be another episode. We will only touch the parts that help us understand the use optimistic. So this syntax suggests that this form must somehow intercept the submit behavior. And yes, it is. Here's a submit for in React. You see that it will create a pending state, and there's a method called start host transition. This one is very interesting. It actually will create the state hook from scratch. Like, there is no use hook for this form, but internally it will fake it. Previously the form doesn't have this MoMA state. Now it have, and it has a full state hook. You see, it's the same as use state. And now this form is a stateful component. It has this state hook, and it will call this transition. That's the same as what we mentioned in start transition here. Start transition, it means, okay, here, start transition, where is it? Here. Start transition, this is the form component, and this is queue pending state, and eventually it will be no pending transition. Then here is the callback. The callback is the async form action in which we will trigger the set optimistic state. Cool. Let's see what happens actually inside of this start transition. Okay. Here's a brief summary. So form has an async action. When it's submitted, a state hook is created internally, and a transition is started. And when the async action is ongoing, these optimistic state updates are dispatched, right? And because the transition is ongoing, we'll get the revert lane, same revert lane as it is. And until the async action is complete, use optimistic will suspend actually, as we expected here, because the async action is not done yet, so it throws. Now let's take a look at this start transition. So this current batch config transition is actually the global transition I mentioned. This is a global flag to indicate the state updates under it should be treated as low priority. Cool. And then this fiber will be be set with the state, right? We here, you see, where is the state? Here, start host transition. This is pending state. Pending state is pending true. And then start host, this is pending state. We will run it here. So this one is actually the state initiation. You put it in the optimistic state. I don't know why it says we don't really need to use this one here, because this one actually it still uses the sync lane for the update. It just just has a revert lane. Cool. And then we'll run a callback. As we said, in this callback is the form action in which we set optimistic state. We'll run it, and it happens to be a promise, and then we will dispatch another action to update the state. Yeah. So the first step is in it, and then it will set to the async one. It is actually a bit complex here. There are two states updates dispatched. The first one is an optimistic update for the form state, which is in the format like this. You see that the lane is high priority lane, the revert lane is transition lane, and the action itself, this one is action actually. This one is action actually. The action is an object. Inside of it is pending true, method get. This is the initial state for the form actually. This will be committed right away in high priority, because I think it's very important for its children to know the form status, right? Another update is dispatched after this form action being run. You see that it has a lane of transition lane because it's used a normal set state. As I said, in normal state, the lane is decided dynamically based on whether it has transition or not. So it's because we've already set up the transition, the lane is low priority lane. There's no revert because this one is not optimistic update. And this action will be a indicator of the promise like object. You can see that it has the state, expose the state. Okay, I think I should update it. Sorry. Let me see it again. Yeah. So status is pending, and eventually this one will be resolved to this one, like fulfilled. Cool. I'd like to point out that both actions, you see that this action and this action are not function. So when they are reduced, the latter one will actually replace the first one. So the first action actually will be just the intermediate. Yeah. So the first updates, wait a minute, when the transition, so because this one is optimist update, when the revert lane is being worked on, actually this one will suspend. Am I right? Yeah, because the transition it relies on is still ongoing. Wait a minute. Chain denable, if I'm right. Transition, where is it? Current transition. What's transition? I think, yeah, it's not null. So, sorry. So it suspends, but actually before this form suspends, the thread, the parent component of this form is already suspended. Yeah, cool. Yeah, as pointed out, the first update is actually intermediate, just like the is pending option for the use transition. As we know that a use transition use transition has two set states. The first one is for the is pending. It will be running high priority, and the next one is in a low priority for this transition. Great. And the last one, we will look at the caveat. I named it as low overlapping optimistic updates. Here's a recording of it. So the problem is if we type the messages quickly in a row, you see that we will see a time that the one and the one sending being displayed at the same time. Well, that's not very cool, right? So what's the problem of it? So actually, it happens even if we just enter one message, but it's just not that noticeable. The problem is I've already figured out how it works internally. We'll notice that when the useOptimistic receive a new state pass through, right? It updates the base state right away. It means that the calculated state will be updated right away. But the revert of the existing optimistic update is going to be in the future re-render. In other words, the reverting of the optimistic updates is in transition lane. It's could be interrupted and it run anytime in the future. That means until that happens, there will be a time that they both being rendered. Yeah, so I think this deliberately designed so. Anyway, this is a known issue. There's a GitHub issue for it. They are working on it, I think. They're considering what's the best approach. But anyway, there's a way to fix this. In our demo is in a dispatcher, we will filter the message by text. Means if the message is already in the wait a minute. When we dispatch it, oh yeah, this reducer will be always run in the for the optimistic updates, right? So if the message is already there, it means that like for one sending, it means the one is already there. I should not be added to the optimistic state. So we just figured it out, and then it works. But I'd like to point it out, like, okay, let's try it out. 1, 2, 3. So it will work like this, much better. But this is not perfect because it doesn't allow us to type in the same letters, same one, like 1, 1, 1. Yeah, this ends up in the weird state. The best approach is we need to dedupe by keys, unique keys, maybe symbols, not by text. Okay, cool. So here's a summary. Please take a look. So it's quite interesting to see how this hook is implemented, and it's quite complex. I don't think we should use it by ourselves, actually. I think it's mostly for the library authors to create their own data fetching libraries. It's quite complex. Cool, that's it. Hope it helps. See you next time.